Welcome back to another episode of MBAs Teach Econ. In this lesson, we're going to look at how we model taxes. So this will be our second lesson on taxes, and we're going to look at a supply and demand model and see what effect our taxes has on that model. All right, so we'll start off with our Y and our X. So this is going to be quantity in thousands, and this is going to be price in dollars, and we're going to look at the gum market again. Okay, all right, so our equation for demand is going to be in PQ format, so price equals a negative Q sub D plus 12, and supply is going to be price equals a Q sub S plus 2. So first, let's put this down on our graph so we know for demand we're going to intersect the y-axis at 12, and you'll notice this is in y equals mx plus b format, where our y is p and our x is q. So demand has a slope of -1, a y-intercept of 12. That means we're going to intersect the x-axis also at 12, in this case 12,000, since this is in thousands. Change colors here and we'll connect those two for demand. So this is going to be our demand. Now for supply, we're going to start out here at 2, and our slope goes up at a +1. We'll change colors to red to make it stand out, and then where we have our supply. Now this is going all the way back to some of our first lessons, but the first thing we want to do is figure out what this equilibrium point is here. So to do that, we set supply equal to demand. So in this case, Q plus 2 is equal to negative Q plus 12. Let's bring the Q's on the same side. So we have 2Q equals 10 and Q equals 5. So this Q here is 5. Let's substitute this back in here for price, and we'll find that price is equal to 7. So price is equal to 7, Q is equal to 5. If we leave the market alone, that's what it'll look like. Let's introduce a tax, and we'll say this is going to be a $2 tax. So right over here, tax, and this is going to be $2. And so the way we model this, we can affect either the supply or the demand curve, and the effect will be the same. But it's much easier to see, and what we've done, the way we've done it in the past, is to affect the supply curve. So we'll continue to do that here today. And so we would find a supply sub tax, so supply sub T is equal to P Q sub S, and then we're just adding our 2. So we're just changing the y-intercept here to 4. So y-intercept up here to 4, switch colors back to red, and we'll draw out our supply sub T, or model our tax as supply sub T. Now we want to figure out, once again, we want to find the intersection of demand, in this case, and supply T. So this would be number 2 here. We're going to set number 2, we're going to set demand equal to supply sub T, negative Q plus 12 equal to Q plus 4, resulting in 8 equals 2Q, or 4 equals Q. Substituting back in for price, and we have price equal to 8. So we'll go back up to our graph and label these points. So this is going to be 4, and this will be 8. One of the final steps, or one of the other steps that we want to figure out on this graph, is also where this quantity 4 intersects our old supply curve. And so we just find that price, because we want to find that price, we just find that price by putting Q is equal to 4 back into our original supply equation. And when we do that into P sub S, we find that our price is equal to 6. So price is equal to 6, so we'll just label this number here 6. Okay, I'm going to put some letters in here to help us later. This is going to be area A, This is going to be area B, C, and D. Now the next question we want to answer is how much tax revenue is generated by this tax. So tax revenue is A plus B, or this area here. In this case, it's just length times width, or 4 times 2, so we generate 8, and this is in thousands, so $8,000 in tax revenue. Much like our previous examples, we're also going to calculate our dead weight loss. So let's see, number 5 here would be dead weight loss, and dead weight loss is going to be areas C plus D. I'm going to change colors over here to green. This is the area of our dead weight loss, area C times D. And so we just find the area of each triangle and then add them together. So in this case, we're going to have 1/2 times 1 times 1. And since there's 2 of those triangles of the same size, we'll just multiply that times 2 and wind up with $1,000 of dead weight loss. We'll also find our consumer surplus and producer surplus. So 6 will be consumer surplus. We'll do this one first. So consumer surplus is the area above A and below demand. Will be our consumer surplus. So quickly calculating that would be 1/2 base times height. So 4 times 4, which is equal to 8. And step 7, we'll calculate the producer surplus. Producer surplus is going to be the area below B and above 2. It's a little bit scrunched together here on the graph I've shown, but it's actually equal to the same thing as consumer surplus. It's 1/2 base times height, or 1/2 4 times 4, which is equal to 8. Now step 8 is something we haven't done before. Now step 8 we're going to find, and I'll do this up here, we're going to find the tax incidence, or how much of the tax burden falls on the consumers and how much of the tax burden falls on the producers. So first we'll do consumers, so the consumer tax incidence first. Consumer tax incidence is going to be A, so this area A right here, over the whole area of the tax, so A plus B. We already know that the area of each one of these small rectangles is 4, so this would be equal to 4 over 4 plus 4, or the tax incidence on consumers is 50%. Producers is going to be B over A plus B. In this case, it is the same as for consumers, it's 50%. And now this tax incidence is not always equal. It's not always that the tax burden falls equally on producers as it falls on consumers. The amount of burden or tax incidence falls more heavily on the most inelastic supply or demand. So if consumers have more inelastic demand, they will bear more of the burden of the tax. I hope this brief overview on how to model taxes has been helpful. So thanks for listening, and see you again soon.